Okay, we're going to look at a couple of examples of separable ODEs. This is a first order separable ODE written in general form. This is the important property of a separable ODE. The right-hand side, side starts with an S. Right-hand side is two functions individually, of one of the dependent variable and one of the independent variable. So if you're given an ODE and it can be written in this form, then you have a separable ODE and you can use the techniques that we've learned. So here's our example. Just read my example. X squared upon y squared. Now this implies that in our previous notation, right, we can write f of x equals x squared and g of y equals y to the power of minus 2. So we're going to go ahead and solve this by doing the rearrangement so that the x's are all on one side and the y's are all on the other. So firstly, you do this with your sort of cross multiplication, treating these infinitesimals just as parts of a fraction. And then we legitimize the expression by putting the integral signs on. Now that we've done that, we can actually do this integral on, do these integrals on each side. So integral of y squared is y cubed. We get a couple of constants of integration, but of course these are constants, so we can actually just rearrange. Now we're typically interested in y as a function of x, so let's go ahead and rearrange for that. And note that I'm just lumping all my constants together and calling it some new constant d. Now, we can go one step further. We just have to be careful with taking this cube root. All right, so that's what we call the general solution to this problem, because it still involves this constant of integration. Suppose that we're given an initial condition. Let's say we're told that y at x equals 0 is equal to 2. That's enough information to identify the value of d, and we just proceed by substitution. So that just we cube both sides and we immediately find that our constant of integration is 8. Oops. And we call this the particular solution for our initial condition, and that was, just to remind us, y naught equals 2.